Moving on to page 89 of the notes now, we've got an example here which uses a loop. Mike, just define for me what a loop is, will you?
A loop is a piece of code that will execute a block of statements a number of times depending on a conditional statement that needs to be satisfied.
So we've got conditional, and we've got the ability to loop over blocks of code. We saw blocks of code before that were inside the braces, and there's the braces, and we can loop over that as many times as we want. Well, let's go through the process now. So first thing we need to do, and we're going to call this one loops, I think. So same as before, create our text document called loops, just a temporary holding file. Now do file, save as, and we're going to call that loops.c, but we're going to do it under all files. And bingo, so there we have it. And inside here we've got loops and loops.c. Well, I'll clean up the hard drive a bit and get rid of that one. So I've got loops.c open. Now the author of these notes, previously we couldn't do cut and paste, but this is proper text here, so we can. So I'm going to copy that, and I'm going to put that in my loops.c. Okay, I'll hand you over to the syntax tidying man, Mike, and we'll see if we can get a build of this piece of code and get it running.
Okay, we've got everything we've already seen before here. The only new addition is the for keyword. I like my braces like that.
I like it nice and neat like that, yeah, me too. That's much better, much more understandable. You can see which brace relates to which one because you've stacked them on top of each other, haven't you? Just highlight that with the mouse, will you? So those two braces are on top of each other, those two braces are on top of each other, so you can see which opening brace and which closing brace. Well, it's just so much neater, isn't it?
So the for statement here has a bit of a interesting way of interesting syntax.
Well, build it first, Mike. Build it, and then we'll explain it afterwards. So let's have a look what that piece of code does. We've still got the other one open from before.
Okay, so
just clear the screen because it gets a bit messy, doesn't it? Yeah. So that's CLS to clear the screen, right?
So we're going to create an output. We'll call that a loop. So we're going to
loops.c.
Loops.c.
Seems to
good. We run that loops and we get hello world 4
So we've got hello world 4 times, but if we look on the screen, we've only printed hello world. We've only got the printf statement hello world once. Run that one by me.
Okay, so what we're doing here is we were supplying a conditional statement to the loop structure, and in this case we're declaring a variable called I. We know how to do that. It's simply int I. We're initializing the variable to 1. Yeah, and this can be looked at because we have this colon here. We can look at this as a simple statement in I equals 1. It's simply.
I'm perfectly comfortable with that.
Yeah.
What I'm not comfortable with is the next bit.
What we do have to be wary of here is that this is not true C syntax because you can't declare a variable and then initialize it on the same line. So this could also be written, and it should actually be written like so. And so what we're doing is we're declaring a variable in I, and then we're initializing it to 1. Yeah. And then we're comparing that variable for less than or equal to 4.
So that second one is like a conditional statement. It's saying I is equal to 1, but then if I is less than or equal to 4, we're going to execute the code which follows in the braces,
in these braces, yes. And what we have over here is an iterative keyword. And what this is doing is every time we compare this conditional statement, we will execute this.
So every time we go around the loop, effectively, we're making I equal to I plus 1.
Yes, this I plus plus is incrementing the value in I.
Couldn't we write that I a different way? Couldn't we write I equals I plus 1? I'd feel much more comfortable with that because then I can see what the codes do. So I plus plus is the same as I equals I plus 1.
Yeah, it does exactly
Fine.
And what we can do is we can look at that because we can add a %d
which
value.
we learned before. So we've got our injection point of our data, and what you've done there is you're now going to replace that %d with the value I, and remember that I is going to go 1, 2, 3, 4, yeah?
Yeah, exactly that. So So we're doing it's exactly the same piece of code. We're declaring a variable, we're initializing a variable, we're comparing the variable for a true statement for every time we run this loop, and every time we run this loop we're executing this code which increments the value of I by 1. We could increment it by 2 or by 3, whatever we want. So let's just try this. Let's go. What we're going to do is we're going to loop it 10 times this time. But after every loop we're going to increment it by 2. So we're actually only looping 5 times.
Okay.
Yeah.
I can see
Okay. So let's compile that piece of code, and we run that. So sure enough, we have 5 iterations, and we have hello world 1, 3, 5, 7, and 9.
Okay.
So to make heads or tail of that, the instruction pointer comes down here. It runs. It looks at this. It initializes I to 1, and then runs, and then prints 1. Because I is equal to 1 at this point. Then it loops back, it looks at it again,
and sees that I is less than 10.
It's still less than 10, but before it's less than 10, it actually, because this happens at the end of the loop. And that's something that's very interesting with the I++ that I'll touch on in a minute, but this increments at the end of the loop. So what's going to happen now is it's going to add 2 to I, so I becomes 3, and then it's going to execute this piece of information here, and now I becomes 3, so we get hello world 3. And it's going to do the same again. It's going to run the loop, but it's going to add 2 to I. So I now will become 5. Yeah. Now, what's interesting about that? What's interesting about that is we can do one thing that's worth looking at. If we just change this to back to I++. You change it like that, which is exactly the same. Now. Now
so run that.
We're gonna run that. I'll change this to 5 so we don't get a whole load of.
We want to be able to see it.
We'll be able to see it. Okay. Now let's prove this point. So we'll run that again. We'll run it. Yes, beautiful. Exactly the same. 1, 2, 3, 4, 5. Now what would happen? Do you think if I done this? What would happen if I put that ++ before I? In this for loop statement.
Well, you're trying to trick me, but something different is going to happen, fairly obviously.
Very good, very good. Let's actually run it and see if we can suss out what's going to happen there. Right. Interestingly, nothing has happened. It's exactly the same. Yeah? However, if we were to add, if we were to look at this, right, look at this ++I and I++, yeah, what that's actually going to do for us, if to putting the ++I before the I as opposed to after, actually tells the situation when to increment I.
So I equals I+1 before the loop is evaluated or after the loop is evaluated?
Yes, that's exactly what that ++I should be doing.
So it's pre-increment,
post-increment, exactly that, and that can be quickly demonstrated in a comparison. Okay, so let's say we have let's initialize I here to I equals 1. Just as
which is true.
Information. Right, so I equals 1, and then we come down here, and if we say, okay, if we can say if I++ is equal to 2 like this, we print a yes.
You got 2 M's.
Yes, this is what happens when you're doing it live. Okay, and we close our curly brace. Okay, so theoretically there, what do we think is going to happen? We want to increment I is equal to 1, we want to increment I, and now is it equal to 2?
Well, based on what you've just told me, that won't increment I until after it's done the conditional part there.
I'm going to just take that out just for a second, and now I'm going to do exactly the same thing, but I'm going to put this ++ before. Okay.
And now I think it's going to print, so print yes 1 and yes 2. So
yes post and then yes pre.
Yes pre, yeah, that's good.
Okay, so if if we look at that piece of code here, we execute that, we have a little print f. I meant it, see, we have a
typo.
print f and print. Let's look at that error message, because we always get error messages. What's it actually saying? Warning, implicit declaration of function print f, because I wrote it wrong.
Yeah,
It can't find that function. Did you mean print f? It's helping me, it's giving me a hint.
Pretty useful.
And it's also telling me the line it's found it in. So I fixed my error. I now try and run that code again. Now it's looking lovely. So now let's run that code. Yes pre. Okay, so yes post didn't get executed, but yes pre did.
So it's done the increment before the loop and after the loop. So the top one is after the loop is executed, and the previous one is before the loop is executed.
So what this is saying is I equal to 2? In this case it's not, and after I've compared it, increment it. And what this is saying is, if increment I first, and now compare it to 2.
Yep, that's really clever. That's really useful as well for different things in controlling loops, isn't it? Okay, so we went a little bit beyond the example in the text there, but that was the example of your first loop inside C on page 89 of lecture part 1.